very briefly about our company. Extivia is a professional services company that's been around about 22 years doing data services for Informix. Actually, the genesis of our company started with Informix Consulting. Over the years, we've grown considerably. We now have about 150 consultants throughout the country, with a large and mature group of those focused on data services. We're based out of Colorado Springs, and we have offices in Denver, Austin, Edison, New Jersey, New York, and a very recent acquisition we made 2 months ago. We now have an office in St. Louis. Just a little bit about how we do business. We have a 100% onshore delivery model. All of our employees are located in the U.S., and our management team has been with us, in most cases, for more than 10 years. We have about 250 active clients. They're all across all industries, pretty much any place where you find databases, transportation, retail, banking, financial, manufacturing, insurance, and many others. We focus on really 4 main areas: data management, business intelligence, data warehousing, portal and application development, and our new acquisition in St. Louis is entirely dedicated to CRM. We try to offer a lot of programs for our customers to make it easy to engage. So depending on the customer's needs and budgets, we do anything from virtual DBA work to full-time contract work. With regards to database management, we can help you from cradle to grave with platform support, replications, health checks, backup and recovery, staff augmentation, migrations, and so forth. We offer short-term engagements where we can just help someone get back up on their system, and in other customers, we assist them in the continual care and feeding of some of the largest Informix installations in North America. As a premier business partner of Informix, we are often engaged by IBM directly to help with database support projects. And not too long ago, we were awarded the IBM Information Management Lab Service Excellence Award. So we have a team specifically dedicated to Informix, who most of which came from Informix at one point or another, who continue to support many of those largest installations. So that's just being a little bit about us. I would now like to introduce our main speaker, Jeff Treece. Mr. Treece is a product manager for Informix and based out of Portland, Oregon. He's worked in the database industry for more than 20 years across a number of roles. Before IBM acquired Informix back in 2001, he was a leader of the Informix XPS development team. Many of you remember XPS. Since that acquisition, he's led development teams in adapting such Informix technology as the range partitioning and HADR in DB2. So that being said, I'd like to now turn it over to Jeff. Jeff, are you online?
Thank you very much, Jack. Can you hear me okay?
I can.
All right. Thank you very much for the introduction. It's my pleasure to be here talking today about a number of exciting things changing in the industry and what business that's driving and how, you know, we've been able to respond to those changes. One of those things is NoSQL, and what that means, you know, is different between different people. Some think of that as everything but SQL, and that's not the way we look at it. I don't think that's a particularly productive way to look at it, and you know, I'll kind of go into some of the reasons behind that. But the way we're viewing NoSQL is not only SQL, and you know, introducing the concept that it augments and changes the way we can use the traditional database. You know, so some of those of us who've been around for for decades in the database industry have seen some things come and go, and this concept of NoSQL has been there in the industry for a long time, and we've seen it in various forms, but now it's really taking hold, and that's one of the things I wanted to kind of start out talking about is why it's taking hold now and what business it's driving. And then I'm going to kind of get into more of the, beyond the NoSQL phenomenon, the hybrid use case where we've got this and we have relational data in real applications and why that's needed and why the time is now for that. And then I'm going to dive into the technology behind this a bit, talk about how we at IBM are leveraging it and implementing it in our product, and how then as a developer or user of the technology, how you can apply it to your existing scene. The world around us is getting smarter, and that's coming from instrumented devices, instrumentation, interconnectedness of these devices, and intelligence between the devices that are being connected. And there's a lot of buzzwords in here, but let me just talk about kind of an example I was reading about the other day. Streetlights, interconnected streetlights. The first thing is that as cities are going through and changing out the bulbs in these lights from energy inefficient bulbs to the new LED bulbs that don't use as much electricity, it's an opportunity to do additional things to these lights, which are distributed all out throughout the city. And some cities are taking advantage of this, and they're putting in such things as temperature sensors, power usage monitoring, cameras, traffic monitoring. So, and then these become instrumented devices. And a motion sensor, for example, on the light, coupled perhaps with time of day, allows it to dim and brighten in a smarter way and save some electricity at that light. But then what happens when you have a grid of these? They're interconnected. They're when all these streetlights are interconnected, then you end up with a grid or a web, and there can be some anticipatory reaction from one light to the next, where maybe if someone's walking down the street, perhaps the lights could come on in response, or monitor traffic through the cameras and take some action based on that. Then the intelligence kind of comes in when you apply other data to that problem. And maybe this is somebody making a 911 call because there's been some type of emergency, and these smart streetlights could then flash or direct the emergency workers into the proper location. And and that's a simple example, but it's a real example, and people are starting to act on these instrumented, interconnected, and intelligent devices. And it's new, and it's early in this technology adoption, so we're going to see more and more situations like this. Smart thermostats have been around for a while, but we're going to see the more interconnected and intelligent use of these things. Same thing with your home appliances to reduce the cost of ownership and reduce maintenance of the consumer electronics and all sorts of other areas. We don't even know at this point where all this stuff is going to start coming in. But it's leading to this kind of broader initiative that IBM has been on for some time, the Smarter Planet, where all sorts of benefits start to flow from these instrumented, interconnected, and intelligent devices. So in the market data area, I mentioned NoSQL earlier and how it's been around for a while, and I have seen it, throughout my time in the database industry in various forms. But now it's gotten the level of traction that we're seeing it affect business in a significant way. So you can see kind of the market, and how it's growing double digits, and the size of that market. And then if you look at this $14 billion projection. This is just, one of many different surveys out there. So I don't think the, actual numbers here are important, but the level of magnitude of adoption here is what I wanted to highlight. All the things around that market that are driving it: mobile, fraud detection, digital ads, market analysis, pricing, billing, customer loyalty, documents. All these things are areas where there's a high data requirement, and yet it's not the traditional structured data that fits well into a relational model. But then what I want to tell you about a little bit is that there's still that requirement for that structured relational data, and that's where we kind of start getting into into what we at Informix are calling the hybrid application model, where you have NoSQL, you have relational, perhaps you have time series, graph data, various other types, and access that through a common set of interfaces. Business trends that it's already impacting. We know that applications have to support mobile, and I was reading the other day that mobile phones, the smartphone, has overtaken now the feature phone, and soon it's going to be. We already know that most people have these, and that's shown by statistics now. But soon it's going to be, almost virtually everybody has a smartphone, and expecting to do more and more with it. I mean, there's already, probably 100 different things that you can do with your smartphone when you start thinking about all the things that you use it for. All the new applications have to be created, and the data is there to work with them. It have to be created with agility and respond to the needs and conditions. And these applications have to be able to use the existing enterprise infrastructure, and that's perhaps the systems of record that have addresses, transactions, and various other things, and the decades worth of infrastructure that's been built up to support the information technology. Secondly, it's the ability to scale to big data and deploy on demand. And we know how important this is to business, and this is kind of another area that's taking off rapidly. What is big data? What is real time? I look at it rather simply, in a simple way personally. Big data and real time just means how much time do you have to deal with the data. So even if you have a small amount of data, but you can't get an answer out of that in the amount of time that you're given, and that might be the time that you have a customer in front of you engaged with you at the cash register, or it might be some other metric. But if you can't get an answer that you need within that amount of time, then that's a real-time problem, and that's a big data problem. But so what that means is that as the data grows, your system has to grow elastically with that, so that you can, the response time that's necessary. The third point on here is that companies everywhere are realizing that they want more interactions with customers. This is engaging the customer with the mobile device, with these new sources of data, RSS feeds, social media, various other things. And the natural language, the language that kind of flows through, is not necessarily well represented in just the old relational model. So these are some of the things that are driving business, and I'll talk later a little bit about some specific use cases that require this technology, and why it's driving business. But that's kind of what's behind this and why everyone's really interested in it. Just a couple of quick notes on data volumes. What's driving that? One of the things everyone is, of course, concerned about controlling cost, and that's, not only the software cost, but the server costs. And you can't simply just, in a sort of unintelligent way, keep adding new things to your infrastructure to take care of these data volumes. Everyone's seeking a smarter way to do that. The unstructured data is growing in today's business, and it's in fact it's kind of overtaking traditional data. That's what we're seeing. There are many things behind that as well, and why that's growing. I'll get into that a little bit later. The increased retention requirements just for regulatory reasons. We're seeing that grow upwards of 15 years requirements for retaining data. And it's growing data, so it's not taking the same thing and keeping it longer. It's growing on both ends. And another thing I wanted to point out is that there are just so many new sources of data, from social media to business documents, presentations, historical documents, images, RSS feeds. I could go on and on from that list. It's not all transactions, inventory, addresses, and things that we're really used to storing in databases. So it's all driving a lot higher data volumes. The first thing I wanted to do really here is talk about a real example that comes out of emerging technology at IBM, supporting this concept of Internet of Things. And I'm sure you've heard the term Internet of Things. It's a phenomenon that started happening some time back, the connectedness of devices, and eventually a term was needed for it, and someone came up with the term Internet of Things, and it stuck. But it's big. It's the streetlight example I was talking about earlier. It's all the connected devices, represented along the bottom of the chart, and what new value that's driving in business, and what changes it's creating in our own personal lives. And then, at IBM, we're keenly interested in having the technology behind that supports it. So this particular drawing, I won't speak to every detail of this, but it shows that we have a variety of devices that need to connect, and there's a device registration that has to happen, where if you want to connect and use that device, you have to know some stuff about it, what capabilities it has, where it's located perhaps, who owns it, and various metadata like that. And then once you get it connected, it starts streaming data and doesn't stop. and that can be a wide range of things. Even today we have light bulbs and that are in people's houses that are connected to the network and respond various ways to outside events. We have, cars. Cars are instrumented, and once you start putting that together with other things that are instrumented, like highways and traffic monitoring devices and so forth, then it does start to change our personal lives. And kind of above that, there has to be a data services layer. Here it's the historian. It's a component of a piece of software. And it has to be able to deal with all these devices that are connected in a smart way. I want to kind of zero in on a particular aspect of that, and that is that the data that starts streaming in from the devices is this NoSQL data. It's not necessarily structured, and it's not necessarily well formed in its schema and what to expect, and that is well represented by a NoSQL or not only SQL model. Whereas some of the other aspects of that data, attributes of where it is, who owns it, its kind of physical attributes, are best represented with a relational model. And the crux of this presentation is putting those two things together. Then kind of along the top, there are various APIs for accessing this, and those are, need to be standard to make good use of the technology. The historian component is the piece of this that that takes all these devices and manages the data associated with it. And what is it at the core? It's really a time series, and time series is measurements that happen in a sequence of time. Informix handles this as a native data type very well, and this is one of the reasons that the IBM team working on this historian chose Informix. There's the fantastic write throughput and the ability to handle the raw data efficiently and with the speed that they needed for the project. But kind of going beyond that, they realized that the time series data type, which is not a typical relational type data, is optimized for the time series, fit their needs quite well. They need to be able to scale this because they're talking about hundreds of thousands of events per second. But Informix works with customers that have power meters, for example, and then you're not even necessarily talking about hundreds of thousands. You might be talking about 20 million. And the technology behind it has been created with that in mind, so that it does scale and it does handle the volume, and the time series type is perfect for that. So that's kind of what started leading the historian team down the path of Informix, and then there's kind of an intercept of Informix latching on to the latest trends and the forward-looking historian team figuring out that there's a convergence of that technology, and that's where we brought in the kind of NoSQL model to the Informix engine, which they really needed in their solution. So if we look at what a device is, so in the historian there's a user, and that user might have devices which it's an actual instance of something, a window sensor or a door sensor or temperature sensor or connected car or something like that. And then there are all different types of devices, and that has to be somehow represented in there. There's there's the data itself, which is well represented with an Informix time series, and that has a particular type. You might be measuring temperature, or you might be measuring something else. And then that as you need to dig in and find a particular measurement, the particular time, that's the data point. And then each device also has capabilities that the program has to know about. What commands does it accept, and other attributes. Why they were looking at NoSQL was simply because this data we're talking about did not fit well into a relational model. And it's not that you can't do it in a relational model, and many people have. It's just that when you think outside the box and look at what's trying to be done, you don't necessarily want to decompose that data across different fields. You don't necessarily want to do joins on that on a regular basis, and there frankly are better models for scaling, for scalability, and dealing with those kind of real-time and data volume problems. So, on this page, which I won't just read all these points, but you can take a look at it, and we'll have the presentation available later if you want to go back and study this more. But the bottom line is that the flexibility and the natural fit to JSON, which JSON stands for JavaScript Object Notation. And it fits well with the way that people need to program this, and it's just the natural language that flows through the solution, and now with it being natively stored in Informix all the way to the back end where the data are stored. So, the team started settling on this, on these requirements to bring NoSQL into the picture. They originally came up with this architecture, and if you kind of look down at the bottom, I know there are a lot of arrows and so forth on this chart, but down at the bottom is the data storage on here. And they have the Informix time series, which they decided early on was what they needed to store the actual data. But then they need their users to be able to define, you know, attributes of the devices and various other metadata. Some of these things fit best in a model where you don't have the schema defined up front. You're adding something more ad hoc or on demand about that device. So this team settled on using this Mongodb Api, and that was a bit of the forward-looking part because they kind of knew that being part of IBM that Informix was coming along with a Mongo API support within the Informix engine. And what they did was they took this, you know, this particular architecture and re-architected it based on Informix, and I'll show you that in a second. But I wanted to point out that the picture is nice where there are, you know, kind of two different data storage along the bottom, but when you get into the using it part, you might want to join between those two boxes at the bottom, index on them, do various things with that data, and that complicates the application part of this picture. So what they did to re-architect it, now you'll notice there's only one box at the bottom. It handles the Mongodb API. So all they had to do was bring up Informix on the right port, and it immediately started talking to their application. And you know, they've told us it was really that easy to port that application that way. But it's got the time series data, and it's got the relational data. It also has the JSON data stored in that one box. And the capabilities of Informix allowed them to simplify their application, bring new functionality to their application, and therefore more value by being able to do joins, index, complex operations that include kind of both ends of that. So what I'm going to do now is launch into the, you know, technical, the technology behind what I've been talking about, and this hybrid model where one application at the statement level can utilize data that might be in JSON storage format, or it might be in the more traditional relational data format. NoSQL kind of compared with traditional relational. Schemaless, you know, if you look at from the application developer perspective, there's an amazing thing that happens when you don't have to write out the whole schema in advance. Because, you know, here's a simple example. It's the metadata associated with a JPEG that you've taken on your digital camera, and which is probably on your smartphone nowadays, by the way. But that particular metadata has got some information about your camera probably, or your phone. It's got what was the speed it was taken at. You know, it's got the resolution of the picture. It's got you know, color information, and a long list, if you've ever looked at one of those JPEG headers, of attributes that are associated with that picture. If you need to do an application that uses that picture in some way, you probably need a couple of those things. But that's probably all you need, a couple of them. So you can devise your application to just use those couple that you need. But know at the same time that if you have a picture from a different camera that has different attributes in addition to those, your application is still going to work. And why is that? It's because you're just pulling out the fields you need from that JSON. And the other ones are there, they come along for the ride, and you can use those other attributes in the future if and when you need them. So this particular aspect of it, the schemaless application, really makes it much more agile for developers. And and so that all sounds great, and it is for the type of data that's well represented by NoSQL and JSON. But it's not so great for some of the long-standing and continuing requirements that are using relational data. It's where things are transactional, where we have operational data, analytics, and static records, and things where we have business information that actually does follow a fairly rigid schema that can be well defined up front, and you know exactly which fields you're joining and which transactions you have to do. The point is that the demand is growing in both of these areas, and that they're complementary. They don't stomp on each other. They're very complementary approaches. So Informix supports two types in the NoSQL space, JSON and BSON, which BSON is the binary format of JSON. You don't generally need to know that because Informix does those conversions inside. It's BSON because it's more efficient and stored efficiently in the engine. But they're sort of functionally equivalent, and one is binary and the other is human readable. We have full index support inside the Informix engine. This carries through to the individual fields within that JSON or BSON document, and because it's implemented as a native type, a first-class citizen within the Informix engine, all of the conversions, the comparisons, the manipulations, and the functions and so forth that are behind that work as you would expect, with any other type of data. I mentioned this. The server automatically does the conversions for you. So this end result is a very convenient programming model and very faster way to get to utilize that data that's stored in there. Another thing that our partnership with MongoDB that was announced, I think, last June, has brought us is the ability to use those public APIs that then in turn unlock all these different ways of getting to the database. So if you use the MongoDB API and you're using MongoDB or Informix, you can transfer back and forth between those easily. You just have to point your program to the proper port, and what we have going on behind the scenes makes all that work. There are so many different languages supported, and this is a huge value. If you've got application code that's written in anything you see on the screen and more, you can continue to work with that with the Informix engine now, and it's all unlocked through this MongoDB API. We've also, there are a lot of different standards out there for graph databases, and we went ahead and certified with a couple of those. Graph database, something I haven't talked about too much, but it's another example of NoSQL where some information that needs to be represented doesn't fit quite so well into into one of the other models, and it's very complementary to the other models. So we're seeing adoption of this and really an embracing of that concept of hybrid. We think that if you're using these different data models, whether it's graph or JSON or relational, we don't think that model should restrict how you have to access it, and that's the philosophy that we're driving in here. That if you've got a relational application, you're accessing tables and joining tables, it shouldn't matter if they're coming from 10 years ago and they're stored in a relational table, or if they're coming from JSON. You should still be able to access those. And we've brought that concept into the Informix engine, and use that as the basis for this hybrid application model. When you look at the different ways of accessing, there's a SQL API, which I think we're all familiar with. There's the MongoDB API, which is the kind of standard way of getting a JSON that's stored in MongoDB. That's along the left-hand side of this. Then behind that, obviously we're going to store the data inside the engine in a format that it makes most sense for that data. It's efficient, and when it actually gets to the disk, we have the concept of JSON collections. We also have the concept of relational tables. So how do you get to these two types of data in there? Well, what we've done is we've unlocked it from both types of APIs, and I'm going to explain that a little bit through an example of how that works and how it flows through. When we get into the hybrid model, let's look at a specific example. In here, there's a relational table kind of in the lower left, and it's the picture is a representation of it, but it's data that tends to fit well into a nice compact and easy to look at table, and that's the partners table in there. And then more to the left is the customer, which in this we've chosen to represent as a JSON collection, and it's a pretty readable format. It's a dictionary where you have a keyword and some attribute associated with that. Within each set of squiggly brackets, there could be any number of these attributes. You could put this into a table, but because there is an unknown number of attributes in here, the number of columns in the table could be quite large, and even for a small data set. And also there could be a lot of blank cells in that table. So this ends up being a very readable and very compact way of representing that data. Then within that same data, you can have indexes, you may have distributed queries. What happens if you're coming in, if you look all the way at the top of this picture, it's a Mongo application, so it's going to be coming into this via the MongoDB API. Now, if it wants to get to the customer table, that's pretty straightforward. That's JSON. That's kind of what the MongoDB API was created to do. You would sort of know how that works. But what happens if you want to use that Mongo application to access the partners table? Well, the query comes in, and and it looks like a MongoDB syntax, because it is, and we're looking for particular records within that, so we have to do that filtering. But inside, that's accessed the way you would expect it to be, as if you'd done the select statement, which would be the way that we would normally access a relational table. And as that data goes on its return trip, it's changed back into what the Mongo application expects to find. So what's returned is a JSON object to that Mongo application. So it's all very transparent. You don't need to know, and you might not even know that that partner's relational table is what you're accessing. On the left side, if we access that, I talked about that a little bit already, but what's shown here is that we've implemented in the server access methods, that kind of add what you would need to the select statement to return that BSON value. So you can, then extending that to, which I won't, but that could be a SQL, just as easily be a SQL select, at the top layer than where it currently is Mongo application. So in this case, we're accessing both types. If it were a SQL application at the top, it could also be accessing both types, and that's how, we can kind of fill in that this entire table. Now, another point I wanted to make about this one is, I'm focusing on two different types of different data models here. That's the JSON and the SQL. There are actually other ones, and we carry the same philosophy through to other ones. For example, time series. Time series could also show up on here. You can access time series natively, and we have very good APIs for handling time series efficiently. But we also have very good APIs for accessing it from SQL. And so you can take that time series and project it onto a virtual table, and then use your standard application tools to utilize that time series. That's the point I wanted to make here, is that it's not just these two, it's all of the different types of data that we bring into the Informix engine. So inside the engine, SQL tables, JSON collections, time series, MQ series, all accessed through MongoDB drivers and SQL API. Now, the applications can fully use those without, without doing headstands and other acrobatics to pull those two different data models together. We know that that's a very high value proposition. We've heard that, from many different areas. But on this picture is another little thing, that the yellow box over to the lower left, lower right, we can bring acceleration to these queries because, we can access them all in a very standard way. Informix has this fantastic technology called IWA, Informix Warehouse Accelerator. It comes out of, the same technology you may have heard of, Blue. It's in-memory technology and more that, that kind of spans these data stored in the engine. And, it allows complex analytics on the data no matter what way it's stored behind in the engine. And this is another value proposition that you may or may not be aware of, but it's unlocks entirely new applications and use of that data and the real-time aspects of it, which I talked about before. I think if you're given sufficient time, you can churn through the data almost anyway and get an answer. But if you only have a second or a microsecond or whatever it happens to be, then you have to look at those real-time requirements. Another area that we do is sharding. So when I was introduced as working on XPS technology brought into the database world this concept of shared nothing and scaling horizontally by just adding more machines to the cluster. So the point there is that Informix has had this for a long, long time, and is that exactly the same thing as sharding? No, it's what sharding is built on, and if you shard is probably another technology terminology that you could look up and see a few different definitions of, kind of like NoSQL. It is sort of this concept of horizontal partitioning like this, but what's kind of different about it is when you put that together with JSON, and then you have a document. So you have one piece of data that's complete. You haven't torn it apart into different tables and columns and so forth. That one unit of data is probably the thing that you're going to be looking at. Then that part of the data can exist on a unique shard, and then you can do whatever you have to do with it or to it on that slice. You don't have to cross the different nodes and so forth. So is that possible with relational? Yes, of course it is. And if you take your time to set up your schema correctly and your application correctly, you can achieve a similar similar value, but it flows kind of naturally from using JSON and NoSQL. Another thing on here is the high availability and scaling. You know, I also in my introduction was that I've led a project to port technology from Informix to DB2. One of those was DB2's high availability disaster recovery, which comes from Informix technology, and that's fully leveraged. You know, that same technology is fully leveraged in here to bring high availability to the sharding for NoSQL scalability. And that's represented in this diagram as, you know, what would be, I forget the exact term in MongoDB terminology, but it's an Informix secondary, you know, in this picture. These, and it's all based on, you know, the Informix flexible grid technology, which is fantastic. It's not just the replication of data. It goes well beyond that to bring to be able to add heterogeneous type hardware to a cluster to do smart replication, where, you know, where put the data where it's needed, to bring the whole grid concept and scalability concept to the problem space. Analytics. We package, in fact, our advanced Informix edition with Cognos, which is a very powerful analytics platform, and you know, I wanted to just reiterate that applies to things that are in collections, it applies to things that are in tables, it applies to things that are in time series. You know, and if you need to take a time series that might be smart meter readings, it's pretty easy to do that, whether it's a time series or not. Time series helps, but if you're looking at, for example, you know, one sensor from one household, but then if you want to ask a more complicated question like, you know, analytics across the households in the city, then that's where putting, you know, the Informix Warehouse Accelerator on top of the time series data and then adding Cognos to that mix and doing analytics on it really unlocks some applications that you could not achieve through other standard techniques. It's just you would take too much time to get the answer that you're looking for. So, you know, our philosophy and our approach to make these standard APIs to build something that can be used in a hybrid way, it starts to pay off when you start putting these different building blocks together, and you can do all this in the Informix engine. Some specific advantages in the MongoDB drivers. There's you know, accessing the traditional SQL tables, time series, JSON collections, all in the same database. Putting the data all in the same database is advantageous, as I illustrated with the historian component earlier. You know, this is not duplicating your infrastructure and buying duplicate hardware. It's not having duplicate administrators and you know, the list goes on and on. So there are advantages in putting it in together into the same database, but then going beyond that to the hybrid application, that's where the true value starts to stick. So then you know, we have the use of the MongoDB client drivers for inserts, updates, deletes on all these types of data in the hybrid application. We have the ability to join with JSON collections and do indexes, not just simple indexes, really any type of index you need to use. And we also have the ability to do stored procedures with these JSON collections. Again, these are Informix specific advantages. So, and then there's, I mentioned, you know, this concept of virtual table or view. You know, we have ways of presenting that data to the user in whichever format it makes the most sense. And so what that allows is the, you know, the use of existing SQL tools to access the JSON data. So, we have this very strong philosophy is if it's been invented, you don't have to go reinvent it, and that's one of the things that people have found with using JSON. Their, famous company, which I won't say the name, but you could go out and, Google it, found that when they started this widespread adoption of JSON, that's what the developers started using, and you can guess why. It's some of the reasons I've talked about, the flexible schema, the agile development and so forth. And that widespread use of that started eventually causing problems, because what were those developers doing? Well, they were having to figure out how to make a transaction, and they were having to figure out how to do indexes and various other things that were not supported in the eventual consistency model of JSON, or in the transactionless of some of the NoSQL solutions. And so those developers ended up reinventing those things, introducing a lot of problems through defects and other brick wall kind of things that had been solved decades ago, frankly. So people who've plunged into the space without having a pretty good view of what's going on have not necessarily achieved the level of value that's possible by using NoSQL and JSON. The final point here is that all of this comes with enterprise level functionality, and that's the ability to do backups, to have security and compression, and there's a huge high availability. It's a huge list of stuff there that we've been building for a long time in Informix, and it's rock solid. I won't spend too much time on this chart, but I did want to just show some of the common everyday things that we see in the Internet of Things and why they need different types of data. They need both the relational and they need the JSON. Starting with something like social networking and online communities, these are more like documents. They're not like tables. If you think about how would you take someone's tweet from Twitter and represent that in a table, you can do it, but it's not a very natural way to represent that data. On the other hand, once you start doing some analytics on that and you want to pull some things out, well, then you may need some information about your customers, or you may need some information about the person, where they live, or addresses, or the things that they bought. And these things are not well represented in a JSON document, at least not to get the full value out of those things, where you might want to actually do a transaction on some of that data, or various other analytics on it. Sensor and machine data, we talked about that. Have some good examples where you need both relational and JSON data or time series. There's the explosion of mobile devices, and with each mobile device there's a whole set of unstructured data that's nicely represented in JSON. But there's also a lot of information about the person who owns that tablet, about maybe what's going on from sensors that are on it, and again, commerce and transactions and purchase histories and inventory and other things that might not be the best operated on in a JSON model, might be best operated on in a relational model. Smart devices, e-commerce, social commerce, targeted advertising. Just a few examples. I'm closing now, and so be thinking about which questions you might like to ask, and I think the moderator might take over here in just a second. I just wanted to point you to a demo that we put together that shares photos, and so it has some of these aspects of JSON collections. It also has relational data, and it uses analytics. We built it with IBM Dojo mobile toolkit, so it runs on a web browser, it runs on tablets. I'll give you the URL, and you can actually go out and try it if you want. You can upload photos, you can view the ones that are on there. And it's all built with the technology that I've been talking about today, using relational and using JSON behind the scenes. Here's the URL, NoSQLdemo.com. You can go there. There's some information as well. If you want to, you can look at the for more information page. If you don't find what you're looking for there, there's a form you can fill out. Give us your address, and we'll get back to you with more information. With that, I'm going to turn it back to the moderator. Thank you very much for listening.
Great, thank you, Jeff. Jack, are you on and unmuted? I wanted to look at a couple questions with you and see which ones you thought maybe best to jump into. We've got just a little under 4 minutes. Of those 4 questions that we have so far, any that you want to pull out and address?
I would just do the most general one since you only have 4 minutes left.
Yeah, let me just take this first one. Is the NoSQL functionality in Informix an additional expense or add-on feature for the base product?
Okay, yeah, that's a good question. So when we built this functionality and realized that we're getting adoption from new users of the technology, people who are experiencing it and building agile applications, we wanted to make it extremely accessible. We wanted to make it available in a free download, and we wanted to make it available in our most advanced product for to get the full value from all of the other Informix features. So the short answer to that question is it's available in every edition we have out there, and there's nothing extra to buy. It's since we have a free download, we have a developer edition. I've given you the link up here on the page. Then you could even be trying this afternoon if you wanted to. You just go out to that page, download it, and it's going to be in that edition.
Okay, great. And we're getting close to the top of the hour, so let me we'll follow up on these other 3 questions to the people who asked them if they seem like, yeah, we'll look through those and get back to folks.
Yeah, absolutely. And you know what? I put my contact information up here too. I'd be happy to receive cards and letters. And even if it's just a shout out, hey, I saw you or listened to you on the web conference. Feel free to contact me, or if you have follow-on questions, I'm happy to take those.
Great. Well, I think we'll wrap it up here then. We've got the screen up here, as Jeff had mentioned, with a number of places to get a hold of us. The one that I don't see up here is just the Extivia website, extivia.com. Most of you probably have been there because of the promotion of the webinar. On extivia.com, on our Contact Us page, there's a form, and these phone numbers also some of these are available there. So, Jack, before we wrap up, do you have any closing comments?
No, just thank you, Jeff, for joining us, as well as all the other folks out there, and Ray, thank you for helping us to put together this webinar.
You're welcome. Well said, and we'll see everybody next time, hopefully, for our next webinar. Thank you.